Okay, here we go. We are looking at 5.4, finishing up the last two problems of that, and 5.5. Two things I want to tell you before we get started. One is during class on Monday, I got an email that I didn't look at till after class. It went to all faculty, all instructors, asking for our input on two open-ended questions about the fall. What are we concerned about? What do we think needs to be done? That's something like that. Two open-ended questions. So they are eliciting feedback from every instructor in TCC. So they'll get some great ideas that they didn't anticipate for what to do about the fall. And they're asking for them jiffy quick because you'll be able to schedule your classes on May 3rd. Some of you have been around for a while. The latest anybody will have to wait, if this is your first semester, you'll have to wait till like May 10th. No classes will be filled up in that time, so don't worry about that. But my point is, by May 3rd, our schedule has to look exactly like it's going to be. TCC is really against changing up classes after students sign up for them. So if we are going to have a class that has half, you're coming on Monday and the other half of the class comes on Wednesday, that's going to have to be written in the schedule. If it's going to be a class that is expected to be completely face-to-face, that's going to have to be written in the schedule. If it's going to be an online completely for those who aren't comfortable coming in, that's going to have to be on the schedule by May 3rd, which is just around the corner. I mean, it's less than a month away. So I guess it is a month away. Anyway, they're going to have to work on that really quickly, and I'm excited about that. I'm excited about finally them trying to decide what to do about what fall is going to look like. So as soon as I know something, I'll let you know. And let's see. Yeah, I just got an email, but it has nothing to do with anything I want to look at. So let's finish up these two sections. The other thing I wanted to tell you, I told you there were two things. The other thing is that when we take the break when we transition from 5.4 to 5.5, I'm going to give you 5 minutes in class to do the course evaluation for this course. I'll show you where to go. I'll give you plenty of time to do it. When we get back, if anybody needs more time, I'll pause for that too. If you finish up this class's evaluation early, go grab another one of your classes and fill out that evaluation too. Every piece of information is so valuable to instructors to make the course better for the next set of students. And it's anonymous completely. It is not attached to your name at all in any way. And it may be, you're saying, yeah, right, it's an electron. It knows who I am. But I don't know who that is. And I know that the department doesn't know who you are. They receive anonymous information. And I don't get to see it until after I've posted grades for the semester. So completely anonymous, completely safe in terms of, me scalping you on your grade because I don't like what you wrote. And I appreciate all the information because it lets me be a better teacher next semester. Okay, let's get going here. First problem we're doing on 5.4, this is nonlinear, so we're not doing lines right now. Systems in two variables. Find the length and width of a rectangle whose perimeter is 40 feet, because perimeter is always in feet or inches. It's the unit to the first power. It's a measure of length, so it's inches, feet, miles, that kind of thing, and whose area is 64 square feet. An area is always done in square feet. Area is two dimensions, length and width. Okay, so this will be the problem. Find the length and width of a rectangle whose perimeter equals 40 feet and area equals 64 square feet. We need to come up with two equations in two variables for here. So let's see what we know about perimeter. I'm hoping that you know the formula for perimeter is twice the length plus twice the width equals, in this case, 40, equals the perimeter. So we've got twice the length. Let's just say we've got our little rectangle here. There's a length and there's a width, although truth be told, if we tump this on its side, then we can call the bottom the length and the top the width. It doesn't generally, in this country anyway, we use the length for the longer and the width for the shorter, but it doesn't matter. So twice the length and twice the width will give you all the way around. The other statement we need describes area. Length times width equals 64. There are two statements. There are a couple of different ways we can go with this. And I think the easiest way we want to go is we want to dilute this. It'll make our life easier. It's got a GCF in it. So let's get rid of that. Let's divide by 2. If we pull out a 2, we'll have length plus W equals 20. If we pull a 2 out of everything. So let's pull out the GCF of 2, and we'll have length plus width equals 20. Let me put that underneath here. And there, that makes me happy. Anytime you can reduce the size of numbers, you want to do that by dividing everybody by the same number. Okay, so we have our two equations. We're trying to figure out the length and the width. We can do either substitution or we can do elimination. I think in this case, it's going to be easiest to do a substitution because I've got one L, I can make it equals everything else, or one W equals everything else. Let's just do it with L, so I'll move that over. I get length equals 20 minus W, get rid of that. So I'm going to use this 20 minus W as my substituent phrase, put it into the other equation in place of length. So in place of length there, I've got 20 minus W times W. We've not had times there, so be careful of that. Times W equals 64. And notice we went from two equations with two variables down to one equation with just one variable. That miracle happened. Let's distribute. So we're getting 20W minus W squared equals 64. Once you see that W squared, your brain goes, this is going to be a quadratic problem. And because we always want the highest exponent to be a positive number, let's move this guy over here. So we'll move this guy over here too, because we want this. So when he moves over there, he's W squared. Then we'll have 20W. He's a positive over here. When he moves over, he'll be negative. And then the 64 is already over there, and he's positive, equals 0. You could move the 64 over here and then change all the signs. That would be the same. We're going to get this as our equation either way. Okay, let's factor. There is no GCF. Let's set up two sets of parentheses. Signs need to match, and they'll both need to be negative. We're looking for two numbers that multiply to give us 64, that add together to give us 20. So let's start with 1 and 64. Okay, those add together to give us 65. That's not much help. So look at 2. Will 2 go in? Sure, it will. Those add together to give us 34. We've gone from 65 to 34. We're getting to 20 quickly. 3 will not go into 64 evenly. 4 will go in 16 times. There we go. There's our pairing. Doesn't matter which one goes where. Set each of these equal to 0. Move across. So we have two possible answers. We knew that because we had a 2 for our exponent. So we've got two different answers here for the width. Let's look at both of them. When W equals 4, let's plug it into either equation. I think L plus W equals 20 would probably be as easy as any. L plus 4 equals 20, so L equals 16. So we've got the possibility of our rectangle, the length is 16 and the width is 4. That's one of the possibilities. And then let's look at when the width is 16. Again, I'm going to use the same equation. L plus 16 equals 20, so L equals 4. So here's our equation where the length is 4 and the width is 16. And it doesn't matter what, it doesn't matter. In fact, let's change that there. It doesn't matter because I've got the width here, the width is here. So it doesn't matter which one is which. So we've got a rectangle that is either 4 by 16 or 16 by 4. that's the same thing. So we really have one rectangle. It just depends on how you're looking at it. Be careful here. Length and width will both be in feet. And I think that matters. I wrote a note to myself that matters. So when you've got 16 and 4, and then you've got 4 feet and 16 feet, be sure it's in feet. Length is in feet, not feet squared. Area will be in feet squared because it's length times width. It's 4 feet times 16 feet. So area is 4 times 16 is 64. Feet times feet is feet to the second power. That's how that happens, in case you didn't know. How do you know which one you input? They'll give you both. They'll ask you for both. My memory is, because they're both correct. We have two different sides, two different ways of making it happen. Okay, let's look at our last problem in 5.4. They're going to give you this. Remember, it's nonlinear systems, because while length plus width equals 20 is a line, if you changed them to x and y, certainly L times W is not a line. Let's look at another system that is not a set of lines. They're going to give you log base y, oh yeah, you didn't lose logs, equals 3, and log base y of 49x equals 5. Give us that system. We're trying to solve for x and y. And that's what they give us. Okay, that looks about as crazy as anything. What you want to do is you want to turn those into exponentials. So let's do our round the circly thing. Y to the third equals x, and y to the fifth equals 49x. Get rid of that log. So turn it into an exponential. Y to the third equals x, and y to the fifth equals 49x. There's our system of equations. Okay. In order to play the game of substitution, you need x equals everything else or y equals everything else. And we've got x equals everything else in this problem right here. X equals, there's our substituting block. Let's go put our substituting block in place in the other equation in place of x. So we've got y to the fifth equals 49, and in place of x, put y to the third. That's kind of crazy. That looks different from anything we've done. Start over. You got to change the logarithmics to exponentials. Y to the third equals x. Y to the fifth equals 49x. And then remember, with substituting, you want to find x equals everything else. And we've got it in the first equation. We got it backwards, but that's okay. Take that y to the third and put it in place of x. Okay, so now we're solving for y. We had two equations with two variables. We've now magically made it one equation with one variable, just y. So what we want to do is get the y's together. Let's divide by y to the third, gone from there. So we've got equals 49. That's cool. If you divide one side by y to the third, you have to divide both sides by y to the third. We get y squared equals 49. Much more comfortable territory for you than some of this other, huh? Put the square root on there. You put the square root on. So y equals both 7 and negative 7. Since you put the radical on, you've got to consider both. However, we're doing logs. We found out y log of that this is the base. We can't do negatives. That the number that you're taking the base of, the number that you're taking the log of, the base, must be bigger than 0, and that one is not. So we ditch that one. Even though we have to consider it, we then ditch it. So you do what you want to do when you do your problems. You're just going to use the positive version. So we've got y equals 7. Let's go figure out what x is. The substituting block will always be the easiest. X equals y to the third. We know that 7 is y. So x equals 343. Okay, so we've got x and y. Let's put them back in here and see what they look like. Log base y, 7 is our base. of 343, because x is 343, equals 3. And sure enough, 7 to the third equals 343. And the other one, this one, log base 7, 49 times x is 343, we'll do this in a minute, equals 5. So log base 7, grab your handy dandy calculator. Let's see, clear it, and we got 49 times 343. 49 times 343 equals 16,807 equals 5. Okay, that means nothing to us, but 7 to the 5th equals 16,807. 7 raised to the 5th equals 16,807. So it works like it's supposed to work. X is 343, that's one of your answers, and Y is 7, that's your other answer. This was just showing you how it fit into the original. Okay, that is 5.4. Hang on, let me get attendance. Take attendance. Okay. Let us take a break from this. Let me, I haven't done this very often. Let me come share a screen with you. Okay. You should be looking at my Blackboard screen right here, course evaluation. If you would go to your Blackboard screen, just go back to that, click on course evaluation, and you can evaluate this course. All of your courses will come up. Click on this one, please. I'll give you 5 minutes. It's 8:18 now. We'll come back at 8:24. I want to give you every bit of the minutes. So 8:24, we'll come back and start in on section 5.5. If you finish the course eval for this one before 8:24, go tackle another one of your classes. And I'm going to mute my mic, and I will see you at 8:24. Any questions before I go? Holler quickly. Okay, enjoy. Okay, does anybody need more time? Holler if you do. I like how you speak for the group. I love that, Ashish. Okay, that's fun, yeah, painless. If you have other classes that you haven't gotten to, please get a chance to go to them, especially if they're asynchronous, because your teacher might not, I mean, you can't take time during class if you don't have a class to give feedback. It just helps. It helps all of us. Okie doke. Let's do 5.5, Systems of Inequalities. This is going to be graphing, but not painful graphing. Graphing that you already know most of what to do. There's a little bit, two tiny little things you have to learn how to do on Systems of Inequalities. The inequality means less than and greater than. So we'll have less than and equal, greater than and greater than or equal. And I'll tell you what you do about those once we've done one of each, because I think it makes more sense after you've done it. You can look at it, see it, feel it, touch it, sniff it, and we can describe it. Okay, so first thing we're going to do is look at 4 single lines on a graph where we shade, and then we're going to look at 3 systems. So let's look at x plus 4y is less than 12. Let's start with that. I want to get this into y equals mx plus b so I can graph it. So I'm going to move the x over to the other side. So I've got 4y is less than negative x plus 12. Because we're working toward y equals mx plus b, we want to get the x in that position so that the slope will be sitting right there in front of us, in front of the x. Now divide everybody by 4. So we get y, yay, that's what we wanted. Got a less than instead of an equal to. Then we've got negative x over 4. You know there's a 1 there, so the slope is going to be down 1 and over 4. Plus 3. There we go. There is our line in y equals mx plus b form. There are 2 pieces of information we have here. One, the slope is a negative 1/4, and the other, the y-intercept is a 3. And I know we've done that. We've done some line graphing. So let's look at how this is going to translate today. There we go. Let's see. The y-intercept is 3, so I'm going to go to 0, 3. There's the y-intercept. That is rise over run. Charles, what are you thinking? What do you mean? Open up your mic if that would be easier. Oh, yeah, good.
Since you have to go like -1, do you have to just go up 1 over 4, or do you have to go 4 over 1?
It is right, like you said.
Okay.
It is rise over run. So we will be rising 1, but it's a negative, so we'll be going down 1 from here. So we start with the b equals 3. Begin. Remember that doesn't really stand for begin, but it may as well. Begin at 3, at 0, 3, so right there. And then we will use rise over run to go down 1 from there because it's a negative, and then positive 4, run 4. So there's our line. You good with that?
Yes.
I waited till you turned off your mic to ask you a question. Okay, let's look at the 2 things that are new in this. The first thing is, does this line count? Well, let's look at it. Let's look at the point, for instance, this point right here, 0, 3. If you put in 0, 3 here, you're going to get 3 is less than, and then we've got a 0 divided by 4 plus 3. You get 3 is less than 3, and no, 3 is not less than 3. So this point does not count. This point does not count. It doesn't say y is equal to this mess. If it had said or equal to, then 3 equals is less than or equals 3, then all on that line would count. But as it is, it doesn't count. Nothing on this line actually will work. 0, 3 didn't work because 3 is not less than 3. This point would not work because we would get a statement that was not true. So this line, we don't have any points yet. We don't have one single point that works yet. but we do right here because we're told that all of the y's that are below this line will work. The half plane, see, what we've got is a situation where we have to shade either up here or down here. It's called a half plane. It doesn't mean literally one half because these go infinitely in all directions. But this dashed line has divided our stuff up into good stuff and bad stuff. One of these halves is good and the other is bad. When you were in school, you probably learned to take a test point, like take 0, 0 and try that out. So we'd say 0 is less than -0/4 plus 3. 0 is less than 3. Is 0 less than 3? Yes, it is. So we would shade where our test point was. We would shade down here. That's all well and good, but it's a whole lot easier to do something different than take a test point. If you take a test point, you run the risk of making the math wrong. You run the risk of once you get here saying, well, no, 0 isn't less than 3, making a mistake there. The easiest way is to go up to this equation and think of it like this. We are going to shade the y's on the y-axis. We are going to shade the y-axis. So think of this as saying the y-axis. We're going to shade the y-axis where the numbers are little. Whatever starts here, little starts there. That's the little side. That's the pointy side instead of the big side. So you want to shade the y-axis where the numbers are little. On the y-axis, the numbers are little down here. They're huge up here. So we want to shade down where down below. Every time it is less than, you will be shading below because the little numbers are down here. If it's a greater than, we'll be shading up there. It's just a light switch. It's a very simple test. So when it says less than, we want to shade down below where the numbers on the y-axis are little. There's something else I want to tell you about this. Okay, this is now the point where I want to tell you that one rule. So I'm going to get rid of this. Let's see. Let's look at when we have got less than or greater than without the equal to sign. Bring that in a little bit. When we have got less than or greater than doesn't have the equal sign, we don't include the line. That's why we dash the line. We don't include the line. We just shade the half plane. Okay, so on this one, we did not include the line, dash line there, because it does not include it here. It doesn't say y is equal to, so we can't draw a line. So nothing on this line counts. It's only the points down below it, in the half plane below it, that count for answers. Anything down here will work in our inequality, in our equation. Okie doke. So what you've got to worry about on these problems, get it into y equals mx plus b, graph it, and then you have to decide two things. Is it dashed or is it solid? And if it is greater than or less than, it will be dashed. I should have done that differently. Let me start that again. You've got to decide, first thing you've got to decide is it dashed or is it solid? If you've got less than or greater than, it's dashed. If you've got equal to's on them, greater than, equal to's, it's going to be a solid line. And we'll do this over and over and over. The second thing you have to do is shade the half plane. Shade the half plane that corresponds. So if it is a less than, you will be shading below the line. If it is greater than, you will be shading above the line where the great numbers are on the y-axis. So y is less than, you'll be shading below. Y is greater than, you'll be shading the big numbers because that's the big part of that inequality facing the y-axis. So those are our two jobs in 5.5, making this a really simple section. Okay, let's look at the next one. We're going to look at the oddities because you've got enough. You've got enough practice doing this, y equals mx plus b. So the next three problems we look at are kind of weirdos. Let's look at y is less than or equal to 3x. Okay, this is in y equals mx plus b form. So we're ready to box that sucker up. He's ready to go. We do not have a number out here, but it's in the form of y equals mx plus b form. So when we go to do slope, we'll grab the number that is in front of the x coordinate, that's 3, and I'm going to put it over 1 right now because, as Charles noted, this is a rise over run thing. So we'll be rising 3, and we've got to run something. So whenever you have a whole number, put 1 over it, put it over 1. And then we will begin at the y-intercept, which is out here, and there isn't one. So we'll begin at 0. This is still a normal line in y equals mx plus b if you've got both variables present. We're going to look at problems today that don't have both variables present, but this one does. So it's a normal one, except for the fact that, you know, it's got a plus 0 out there that's kind of hidden. Okay, let's go graph that and do the shading for that. Wipe off my little whiteboard. This is just the coolest thing. I love this board. Okay, we are beginning at 0. So I'm going to begin right there at 0. And then I'm going to rise over run. I'm going to go up 3, 1, 2, 3, and over 1. And then I've got to decide, 2 things I've got to decide here. Is it dashed or is it solid? Well, it says or equal to. So it's just like the old-fashioned line that we used to have. We're going to draw that in like we would have done y equals 3x. So solid line when it says or equal to, because it means this all on here counts. All on this is valid. We include the line when it says or equal to. And then which half of the plane, which half plane are we going to shade? Okay, this says y is less than or equal to. So the y-axis, we need to shade where the y-axis has little numbers. And it's a little awkward when it gets angled like that. I get that. Let me see what I can do about, there we go. I get it that it's a little bit different when, there it is, y is less than or equal to, when you're trying to find it as this gets steeper and steeper. But still, think about on the y-axis, you want to shade where the y-axis has little numbers. This is the y-axis, little numbers are down here, so we're going to be shading all of that for eternity, you know. I mean, it goes down forever. So all of this and up all of that, this side of the plane. So we have 2 spheres here that are included. It's all of this half plane for eternity and this line. This line counts also. Any point on that line will work. Let's just take 0, 0 so I can show you that it will work. If we test 0, 0, we'll have 0 is less than or equal to 3 times 0, and you know that 0 is less than or equal to 0. It happens to be equal to, but it is one of those things. So it works. That's why 0, 0 is part of a solid line indicating 2 parts of our graph count here. The line itself and the half plane that includes where y's numbers are little. Okay, in a classroom setting, I'd be able to look at you and you'd be a little more comfortable telling me, I don't get when we're shading above and below. Right now, you can't, you know, it's not as comfortable to you. But if you are not understanding exactly why we're shading down here as opposed to up there, hold on, let me do 2 more, and I'm hoping that you will understand it. If not, as we start on the double graphs, I want you to say something, and we will see if we can't figure it out, if I can't explain it in a better way for your brain. Okay, let's look at our third one. Clean that off. See, let's look at x is greater than or equal to -2. Okay, this is not a normal line. We are not. That's a weirdo line because this is an x line. That means, oh, let's see, it looks good now. Is it good now, Chloe? Okay, yeah, that sometimes that happens, and it doesn't happen for very long, thank goodness. Okay, so when you've got, let me just start over with this. I didn't say that much. You can go blah, 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 and not listen to me for a second if you want. God, you must get tired of my voice. We're almost there, folks. We got 4 more weeks. We're getting close. Okay, this is an x equals line. So just like before, just like what you know about single letter lines, in this case, x equals, we're going to find -2 on the x-axis, and then we're going to draw a line perpendicular to the x-axis. So it'll be that kind of line, okay? Let me do that on my little board, my handy dandy board. So on an x equals line, you know it's going to be a vertical line. So let's go find where x is -2. There's 0, 0, there's the origin. Let's go over here to -2. And then when you're doing my math lab, if you're not matching, and I don't think you are matching, you're going to have to, my math lab doesn't know what you mean when you put that 1 dot. Your brain knows you want it to do this, but you're going to have to let my math lab know that. So grab another point, grab, right here, that's good. So that my math lab knows that you want that line. 2 points determine a line, so my math lab needs to know a second point from you, as you were doing before. Okay, so this says, now what we need to do is decide there are 2 things. Is it dashed or solid? It's going to be solid because it says or equal to. So let me draw that in. There's my line. That's the line x equals -2. That's the line x equals -2. We don't want x equals -2. That's part of it. That's a good start. And now we need to do the greater than. So go on the x-axis and find where the numbers are bigger than -2 on the x-axis. Shade where the x-axis has numbers that are bigger than -2. Well, over here is where the x-axis, the number line, has big numbers. So we're going to shade over there. That's the half plane that we're shading, the right-hand side, along with this entire line. So we did a solid line because it says or equal to, and we did over here on the right-hand side because that's where the x-axis has big numbers, and that's the first thing you see in this inequality is the big side. So shade where the x-axis has big numbers, and that's the finished product there. You will be clicking on a paint can, a little tiny paint can that they have on your tablet on my math lab to then touch your screen over here to let it know you want this part shaded, and it'll paint that side. If you want it unshaded, you can either clear your graph or you can click the paint graph again, I think, and it'll unshade it. You play with that. That's a toy. Okay, let's look at another one. Let's look at our last one of these singlets. Y is greater than x squared plus 7. Okie doke, y is greater than x squared plus 7. This is in y equals mx plus b form, but this is a parabola, and he's got a positive in front of him, so we know he's going to open up. He's not going to shift on the x-axis because there's no x minus, 2 in parentheses. So he's not shifting. There's no horizontal shift, but there is a vertical shift. We're going to go up 7. So that point right there that would be on the origin is going to move up 7. So let's just do what you know how to do. May have gotten a little rusty on drawing parabolas. I get that, which is why I went over it the other day when we had that opportunity. Okay, let's see. The normal parabola would start at 0, 0 and fan out this way, but we're going up 7. So we're going up to here to draw our parabola. So just draw it in. Oh, wait a second. Don't draw it in yet. The first question you have to worry about is it dashed or solid? This does not have an equal to. So we're going to do a dashed parabola. Something like that. Nothing fancy. You'll be choosing it. Or saying it has to go up 7, you know how you have to do that. And then we want to shade either outside or inside the bucket. That's what we're talking about here, where the y's are greater. What you need to know here is that we're doing the same kind of thing. What you've got is you want to shade the y-axis where the numbers are greater. Good. Excellent, Chloe. Exactly. You want to shade the y-axis where the numbers are greater because that's the piece of the inequality symbol that's facing the y-axis. Here's the y-axis. Big numbers are up here. Little numbers are down there. So you'll be shading inside the bucket. Okay, you'll have one of those parabolas. Okay, now let's, most of that, not much news there. Now what we want to do is we want to look at systems of inequalities. We're going to look at 2 lines at a time. So let's start with 2x minus 6y is less than or equal to 12, and 3x minus 3y is greater than 9. There's our system. The only thing that has changed is that we've got greater thans and less thans instead of equal signs. And instead of solving by substitution or elimination, because these are inequalities, we're going to need to graph them to get a hold of where our answers are. Where do the 2 half planes cross? This will create a half plane. We'll have a solid line going on. This will create a half plane, and those half planes will cross somewhere, and that's our answer. Where do the 2 half planes intersect? Where are the points that are in the painting for this one and in the painting for that one, for both? Let's see. Okay, one other thing I want to go over here. Up here, when we were looking at, okay, Christine, how far? I don't think I'm going to, I'll say that again. I'll say that again. Before we move on to this system, I want to cover the other ground with this. Less than or greater than don't include the line, just the half plane. So the rest of that is kind of implied, but I want to write it down anyway. Greater than or equal to, or less than or equal to. When they include the or equal to lines, do include the line and the half plane. Okay, so when they have or equal to, they do include the line and the half plane. If they have or equal to, they don't include the line. So we do a dashed line here, we do a solid line there. Okay, let's jump into these 2. We want to get both of them into y equals mx plus b. So you're going to have to go off to the side and do some work to get them into y equals mx plus b. I'm going to take the first equation first. So 2x minus 6y is less than or equal to 12. I'm going to move the 2x over. So negative 6y is less than or equal to negative 2x plus 12. And then divide by negative 6. And you know what happens with an inequality when you divide by a negative number. So watch out for that. We get y. The inequality will flip because you've divided by a negative number. Negatives cancel here. 2 over 6 reduces to 1/3, and then minus 2. So there's our first equation, inequality. It's both. It's an equation and it's an inequality. The slope here is 1 over 3. The y-intercept is negative 2. Let's go graph that. We'll graph one at a time. So let's see. We're going to begin at negative 2. And then the slope tells us we're going to go rise over run. This is going to be, remember, this is now the point. That should all be fairly boring to you at this point. I mean, there might be a challenge or two, but we've done this. You've done it in other classes. We've done it in this class. Now we've got 2 new steps. Is it dashed or solid? You can see it's going to be a solid line because of that equal to. So this will count as part of our answers. And then you need to decide which half plane to graph. If you're going to graph the half plane above or the half plane below. Let's see, it says y is greater. So you want to grab the y axis where the greater numbers are. Here's the y axis, greater numbers are up top. So we're going to shade above the line. All of that is our answer that lies on the line and above it. Okay, before we move to the other one, holler if something doesn't make sense here to you, please.
So when we're shading, is it always going to be like, for instance, if it's like greater towards the y, is it always going to be above the y, or is it going to be below the y?
It'll always be above. If it says greater, it's always above, because that's where the greater numbers are on the thermometer. They're above.
Okay.
Anybody else? Okay. Ashish, is everybody happy with that now? Oh, wait, no, Chloe's not. What about if it says negative y is greater than? It won't, because if it says negative y, you will have divided by negative and you would have flipped the inequality. So it will not say, you don't care, nobody cares about negative y. Does that answer your question, Chloe? Good, good deal. Okay, Ashish says we're ready to go. By golly, we're ready to go. Thank you, Ashish. If anybody disagrees with Ashish, please speak up. He doesn't always get it, although I think he does always get it right, actually. Okay, let's look at our other line. Let's look at 3x minus 3y is greater than 9. We're going to do the same thing to that one. So let's get it into the form of y equals mx plus b. Move the x across. It's greater than. This 3x turns into a negative, you know that. Turns into his opposite when he crosses the inequality. Now we're going to divide by negative 3. Be sure you're dividing by both the negative and the 3 because we want to get just y there. So let's see, we get y. We divided by a negative, so flip the inequality. Negative 3 divided by negative 3 is 1, x. And there we go. There's our equation. See, slope is 1 over 1, because 1 is the number in front. We don't have a denominator, so make it 1. Any whole number will have its denominator be in negative 1. And then the place to begin, the y-intercept, is at negative 3. So let's go graph that. I got so carried away with Ashish that I erased everything. So let me put the first one back on there. Negative 2, up 1 and over 3, solid line, and we are graphing above. Okay, there we go, back to where we were. Now let me, on top of that, graph our new line. Our new line, the place to begin is negative 3, right there. We're going to go up 1 over 1, right there. And then this is where the new stuff is for this section. You have to decide if it's solid or if it's dashed. I'm looking at it doesn't have an or equal to. So the points that are on the line itself don't count. We're going to have to dash this. Something like that. And then we need to shade where the y-axis has numbers that are little. And because it's less than, we're always going to be going down where the little numbers are on the thermometer. We all live in Texas, but we saw where little numbers are on the thermometer in February. So we're going to shade down here below the red line, like that. The answer to this, well, let's start with the question. The question is, where do these two half planes cross? What do they have in common? And so you're looking for where you've got Chris's and crosses, where you have got the red, where I have got the red and the blue. So the part of this whole entire grid that is the correct answer is this little wedge up here, this little pie here that is bounded by the dashed line, the dashed red line, and the solid blue line. That little sliver of pie that's in there starts about right here and goes out there. And so if you're matching on my math lab, it isn't, let's see, yeah, maybe it starts there, but I don't think so because the red is a little bit above. You're not looking for a point, you're looking for a region, you're looking for what's called a half plane. You're looking for this piece of the pie, a section. And so if you have, you'll have to play around. You might want to do this on your own graph paper or your own sloppy graph. It doesn't have to be fancy. Once you put your two lines onto the graph, then click on the segment, click on the area where you want it painted. Unless you're matching, and I can't remember, it doesn't matter. You should be handling both. So put your lines on there. Do this on your own. Let me start over. Scribble this on your own paper. Then put the two lines on my math lab and paint the section that you need. If you get too much painted, it's not difficult to unpaint. You click in this section and then you hit the paint. It's already painted, so you unpaint it by clicking on it. It's a light switch. If you click on it, it'll paint it. If you click on it again, it'll unpaint it. So you want only this section painted. That's what your answer will be. Where do the two half planes intersect? Where do we have red and blue happening? And that starts in this little corner and goes out in the upper right-hand edge. Okay. Anybody not comfortable with that? Say something, please. Okay, let's look at our next one. We only have two more of these. We don't get too in-depth here. Remember, I told you this last unit is kind of a comfy unit for us. There's not a whole lot going on, and what is going on is not too difficult. All right, let's look at x is less than or equal to 5, and y is greater than or equal to -2. There's our system. Both of those are weirdos. Both of those are going to be perpendicular and parallel to axes. They run straight up and down on our grid. We don't have to do any manipulating there. We've just got to figure out what we're talking about here. So let's see what we can do with that. X is less than or equal to 5. Yeah, that's good. That's better. Yeah, it'll get it. Okay. So go find where on the x-axis you have a 5. On the x-axis, 5 is right there. And then for my math lab's purposes, you're going to need to let it know another point. You need to know that an x equals line does not run parallel to the x-axis. No, it runs parallel to the y-axis. So you're going to have to put another point on there for my math lab's purposes so they'll know that you know that it goes up and down. Because look at these points. That's 5, 0. This one down here is 5, -2. This one up here is 5, 4. All of them start with an x coordinate of 5. That's why that is the line that is named x equals 5. Okay, two jobs here that you have to decide that are new for us in this section. Is it dashed or solid? You can see that it's going to be dashed because it says or equal to. So let's draw that in. And then we need to shade where the x numbers, where the x-axis has little numbers. And that is actually literally pointing us in the right direction, and it will always. So we want to go on the x-axis on the number line, and we want to shade where the x numbers are little. Well, they're little left-hand side, so let's shade all of this left-hand stuff. Okay, that's our first graph. Let's look at our second inequality. Same thing, it's a one variable equation or a one variable inequality. We don't have an x in here. So we know we're going to have a horizontal line, go to where y equals -2, y equals -2 right there, and then let my math lab know that you know it's a horizontal line. So pick another point, maybe right there. And sure enough, let's look. All of the points on this line will have a y coordinate of -2. This point right here is 0, -2. This point is 2, -2. This point over here is -7, -2. So the y coordinate on all these points is -2. And we want a solid line there because it says to make a solid line there. And then it says to graph where the y-axis has big numbers. So here's the y-axis, big numbers are on top. So we'll be shading above. Always greater than means shade above when you have a y. Greater than is, where the sky is. Less than is where underground is. So the answer to this, the system, is where do these two half planes intersect? Where do I have red and blue? That's the portion that is correct, that is full of answers that will be good for the first one and good for the second one. So clearly, it's this quadrant up here. It's that upper left-hand corner. It's not these. None of that shading will work. None of this shading will work for both lines, for both half planes. It's this group right in here that counts. None of the rest of it does count. Any point in here, let's grab a point in there. Let's grab that point right there. That point is -2, 2, 3, 4. -2, 4. So let's look at the point, -2, 4. Our first line says the x has to be less than or equal to 5. So let's put that in. -2 is less than or equal to 5. Yeah, all negative numbers are less than or equal to 5. So that works. Let's try it in here. 4. 4 is greater than or equal to -2. Yeah, 4 is greater than or equal to -2. So this green point works, and so do all of his cousins that are hanging out with him here. But this is your answer, this quadrant, not that green dot. All of these points work. On the blue line works, on the red line works, and that whole intersection up there. Okie doke. Let's do one more. This is a fun little interesting one. 2x, let's start a fresh sheet. Okay. 2x minus 7y is less than 5, and 2x minus 7y is greater than 5. It's kind of a trick problem. Let's see how it tricks us. Okay, let's get these into y equals mx plus b form. So I'm going to start with the first one. I'm going to move the x over to the other side. I'm going to divide by -7 all over the place. So I get y, and then we divide it by a negative, so flip the inequality. Wow, that dry front has come through. This is my very favorite time of year because I get to leave my windows open. And so I've got a breeze running through right now that has gotten suddenly much cooler. I know that the wind is going to shift from southern, because it was so humid this morning, into more western in a couple of hours, or within this hour. Yeah, so it's happening, I can tell. Got negative over negative, so cancel those out. And then minus 5/7. Okay, this has got some fraction going on for our y-intercept. That's okay, we can handle our y-intercept, we can handle that. And it's good that you would get some practice doing that. So slope is up 2 over 7. Y-intercept is negative 5/7. We're used to whole numbers. Let's see how that's going to look. We'll graph that. Do some mess in here. Okay. Okay. The y-intercept is negative 5/7. That's like a half, 3.5. Negative 3.5 over 7 would be minus 1/2. So it's a little more than half. So there's 0. There's negative 1. We want somewhere between there. So a little more than negative 1/2, somewhere like that. You're not going to have to be precise here. They'll handle that for you. Now let's go up 2 and over 7. So see how I'm almost sitting on the line. When I go up 1, I'm almost sitting on that line. When I go up 2, I'm almost sitting on that line. So temporarily, I'm like right there. Now I've got to go over 7. So I end up right here. something like that. Up to takes me, this is like a potato almost sitting on that line on that table. The potato sitting on the table wherever he goes. Okay, are we going to do a dashed or we're going to do a dashed? So let me connect these up. Doing a dashed line. And then I want to shade where the y-axis has big numbers. So that's up above. Sure enough, you can see we caught up in there where the y-axis has big numbers. Okay, let's look at the other line in this system. Okay, we've got 2x minus 7y is greater than 5. Get that x over there. Divide everybody by -7. This is very familiar because this is what we did before, except it's a little bit different. That was a greater than. We're dividing by a -7, so let's turn it, flip it to a less than. The negatives cancel out. There's our y equals mx plus b. Slope is 2/7, same slope. Y-intercept is -5/7, same y-intercept. So let's look at what that's going to look like now. Okay. The y-intercept is -5/7 right there. We're going to go up to and over 7 right there. Now we need to decide if we have a dashed line or a solid line. It doesn't say or equal to, so we want to do a dashed line. This will not be part of our answer. And then we're shading where the y-axis has little numbers. It's shading, it's telling us to go shade down below. And so the question is, where do these two systems, where do these two lines intersect each other? What do they have in common? They don't at all. Good, Chloe. You might be led into, okay, with the half planes, you can easily see that the blue and the red do not intersect. So you've got to worry about the line. Remember, the line does not count. It is not part of the answer. So for the blue half plane, it does not count that. It has to be on the upper side. For the red half plane, the line does not count. It has to be just below the red line. So we don't have anything in common. There's nothing in common. So what numbers will work here? No numbers will work here. Where do those systems cross? They don't. We use the null set there. There is no intersection. There is no commonality. We could easily make it have an answer if we just absolutely wanted to make this have an answer. The way to do that would just be to make this an or equal on both of them. If we had or equal to written there, then that would be a solid red line. And if we had or equal to written here, that would be a solid blue line, and they would have the line in common, but they'll never have a half plane in common. So that's just kind of a goofy one to make your brain think. We're done. We are done with 5.5. Grab this. Done with those last two problems on 5.4. We've done all of 5.5. The best thing we're going to do all semester long is chapter 6. That'll be next week. But we're done for today, so starting our weekend early. Have a good rest of your week, and I will talk to you on Monday. I think that's it. If you want to stick around and ask a question, please do. But otherwise, I will see you Monday. I'm going to stop the recording.